Hello everyone, welcome to day 4 of learning Web3 with me. In previous video, we made a smart contract for a shared wallet where we learned more about how to write scripts for your smart contract and pretty much more optimization for a smart contract to say yes. Today, we have made a similar but unique smart contract which is also very popular in Web3 world for beginners. It is called the voting smart contract. Okay, so what it basically does is it's a platform where people can come and they can make elections for anything. So, like, suppose you have a committee in your college and you want to make elections for it, you want to choose a candidate for it. Okay, so you can create your election over there where you can, initialize your candidates and what party is it from or what committee is it from, and people can come there and vote for their preferred candidate. So that's what we made today. Let's jump right into the code. So today's code is pretty big, pretty huge. It's around 150 lines of code, around 140. Okay. So obviously I'll not go in my life. We all know what are these few words and letters written over here. This is basically some initialization for the candidate. It requires name, party, and votes, and is the start for the elections. Is the name of election, description, start time, end time, and the candidates structure. It's like arrays of candidate structure and the mapping for every address if he has voted or not. Okay, and then the list. Now we have a mapping for every election ID, which refers to the that particular election. Okay? And yeah, the owner has been set with the construction. Constructor which sets the owner and sets the first election ID as 0. These are some events that will come on later. This is the function for creating the election. These are the parameters that will require the name, description, and output. And this is the logic. And firstly, it will require that it's the owner who is executing this function. Okay. Now there is the basic condition, and here we are, uh, keeping those values. So like whatever value we are getting from the parameter, we are keeping those in that particular new election that we just made right here. Okay, and yeah, then we are just simply inserting the values of the candidates in the candidate array using a for loop, and yeah, then we emit the function which is election created. Okay, with all these values, and then yeah, we'll just simply return election ID minus 1 because we are implementing the election ID by 1. So we are going to return the election ID minus 1. Okay? But basically, when it was constructed, the election ID would be 0, and after creating an election, it will be plus 1. So we'll have to return election ID minus 1. Some basic logic, what we used to write in our DSA journey of C++ or Python, whatever you write it. So, like what I have learned in Solidity, yet if you know a good amount of DSA, and I'm not talking about the advanced graph and dynamic programming and all. If you know a good level of logic building around arrays, linked list, mapping, hash maps, So yeah, you can pretty much make logic in Solidity smart contracts also. Okay, let's jump ahead, and this is the vote function. It lets a user to vote for his preferred candidate. So yeah, it will require two parameters: the election ID and the candidate name who you wanna vote for. Now it checks that firstly it checks that if the user is voting between the time of that election. Okay, so we specified the start time and end time of that particular election. So yeah, we'll first ensure that whatever transaction is being made, that transactions block stem. So like whenever you make a transaction, it's being stored on the blockchain, and that particular block in where the information of that transaction is being stored, उसका timestamp is between the start time and end time that we initialized while making that election. Okay, I hope you get it, and if it's not, we'll just revert an error called election not active. Okay, then we'll just check that uh, the user has already voted or not. Okay, this is what checks it, and then if it's all the check cases are passed, then we'll just set the user who is just voted that yeah, when you are voted, let's mark you as true. Okay. Then this is some interesting stuff over here. Okay, now what we're doing here is we're finding the candidate in the election struct and then incrementing it by one. So we are running a loop. Okay, what we did here, we marked that okay, this user has done their voting. Okay, now we'll also have to mark that candidate. We'll have to increment that candidate's vote plus one. Okay, whoever we have voted for. So what we're doing is we're running a loop on that election, जो पर्टिकुलर इलेक्शन है जिसे हमने वोट करा है उसके कैंडिडेट्स के एरे में हम लूप चलाएंगे. ओके, bear with me, and firstly we'll check if keycheck 256. Now what's keycheck 256? Let me show you something. Okay, let's keycheck 256. Okay, so keycheck 256 is basically a cryptographic hash function that produces a precise 256-bit output from any input. So it's basically a hashing algorithm that lets you encrypt some string or any data that will be provided to you. So like suppose I give him like my name is Bhavish Jain. Okay, let's give it Bhavish. So if we apply the keycheck 256 hashing algorithm in it, so it will convert it into something this. Okay, random bullshit encryption. Okay. So yeah, that's what happening over here. It is, now why are we doing this? We are doing it so like the candidate name that we have voted for, उसका collision ना हो which is with the name which is already there in the candidate's name. So like how do I say it? Whatever input our user has given in this parameter, that should not collide with the candidate name stored in our array while creating this election. I hope you get it. Okay, that's the most brief answer I can give you. Okay, so yeah, we are checking that if election of this election ID, इसमें जो candidates array है उसमें से this particular candidate first will encrypt it using this. Okay, let me do this. Okay, so for this particular candidate, first encrypt his name, then if it is equal to the encrypted name provided by the user who's trying to vote, then what we'll do is we'll implement the vote of that particular candidate and we'll emit the event voted successfully and we'll break out of the loop. Okay. I hope you understand what I just said right now about the encryption and hashing of these two names. Okay, it's really important, or else, it's not that important if you code in any other language, but Solidity's compiler is kind of sensitive. Okay? So yeah, he needs this. So yeah, we emitted the function, emitted the event, and then so yeah, these were the two main functions in action. Okay, creating the election and then voting. Okay, all of them uh, are the getter function. Okay, this will give us the result who is the winner. Okay, just simply running the loop over the candidates of that particular election, and it's a simple logic of finding the highest value in the array. So yeah, and they will return that. Get election will give you the election information. It will give the ID of it. Okay, and yeah, it will return this. This is information. If you give the election ID of that particular election, and get all candidates will give you all the candidates of the particular election. Okay, what we ओके इसमें तो हमने बहुत कुछ सिक्योरिटी वगैरह एंड many more optimization and logic building सीखा. What extra did we learn today is this test test file. Okay. Now in the previous video, I was fed up by writing this, console commands to test our application to use this function. Okay, so today we have learned something which are called tests for our Solidity smart contract. Here we can write tests for our smart contract using a simple file over here, src and test or something. So yeah, using this we can write some test according to our need. Okay, so we are making a contract for election test. We are inheriting this particular file, and we are initializing the contract first by setting up these values like the owner, this contract, and there's this particular statement over here. So like two main statements. Owner is equal to vm.address 1. Okay, so what it basically does is we are setting the owner as VM. Now what is VM? VM is basically virtual machine. So like whatever Anvil will create, first Anvil will create the blockchain environment in a local system. उसका जो first index का address होगा, it will be our owner. Okay, and then the VM will be start prank. I don't know why the name of that function is start prank, but yeah, it kind of starts the virtual machine. Okay, then yeah, the owner one. Okay, yeah, and this will create a new election contract. Okay, new election contract. So like this particular code will deploy our contract on the local blockchain environment we just created. Okay, and this is the test create election function. Okay, this particular function will help us test all the cases of this particular function that we created called create election. And yeah, we don't have to write all those console commands to send the transaction and test if our Solidity smart contract is working correctly or not. Okay, so yeah, we will set up some demo data here, and then using these data you can see name, description, start time, end time, and candidate names, party names, and the election ID. Okay, all of these ones get uh, initiated. Then we can call this function, which is election.getElection, where we'll set the election ID, and in election ID we already have the returned election ID from this particular create election function. Okay, so yeah, and get election method that we created over here, it is giving us the information. Okay, so I'll explain in the easiest term what this test is doing. First we'll initialize some demo data. Okay, then we'll call the create election function using these demo data. Okay, it will return us, I'll show you, it will return us the election ID. Okay, the election ID of that particular election. Then we'll pass that particular election ID to get election method. What was get election method? It will give us all the information. It will, if we provide him the election ID. Okay, then we can get all the data we require, and these are the statements, the actual statements to perform the test. So basically assert eq is assert equal to means if this data is exactly equal to this data. Okay, now what is this data? This is the data that we get returned from get election, and this name is what we initialize. So if these two matches, that means it's working. Okay, that's what we put and that's what we get. So yeah, it's working. I hope you guys get it. Okay, that's what he's doing for all of them, like name, description, start time, end time, the candidates, and votes, parties. So yeah, that's a script test for create election. You also have a test for vote successfully method. Okay, for this function वहाँ पे भी यही हो रहा है कि फर्स्ट विल initialize the voter. It will initialize some. Okay, first it will create an election. Okay, first it will create an election with the same demo data, and then we'll call the vote function. Okay, we'll call the vote function that I want to vote in this particular election ID to this particular candidate. So yeah, please do it, and then we'll, yeah, once it's been done, then we'll make an array of candidates. Okay, where will we get the candidates from this particular function over here, get all candidates. Okay, so yeah, for this particular election ID. Okay, and then we'll just write all the test cases again. So like check if this particular candidate name is equal to this, and does it have this actual number of votes or not. Okay, so let's try to see it in action. Okay, let me just get our console over here and go to what and now we don't even have to do the anvil or forge build or getting like, that's it. We just have this test file and we have to run that only. Okay, so there's this parameter that we have to pass. I don't know what it is. I honestly don't know what it is. I'll look into it later. What? Let me just look at it now. What is until in forge? Okay. Empty flag is an alias for match test. Oh, okay, okay. So empty is a flag for match test as we read right now. Tests it matches the all the tests written in the test file. Okay. So yeah, that was it. And what do we have to do? Yeah, we have to specify the function name of which test function do we wanna. So yeah, I think that is it. What we require. And if I run it, we'll get an error. What kind of a similar argument exists? What do you mean, mother? Oh, okay, never mind. I didn't do it. Just okay. So here we have some output. It says that compiling the three files has been compiled. These three files, this, and probably this. Oh yeah, yeah. Since compiler ran successfully and ran one test for test folder में जो election test वाला contract है, that particularly he ran this function test create election. It took this much amount of guess and the result was okay. It has been passed. And you know, if we wanna see the logs for it, we can do this. Wait, what? Maybe. Oh, we can get the logs and look at something what we have over. You know what? This is not what I wanted. Yeah, this is what I wanted. वो बहुत सारा jargon metadata आता है. This is what actually what I mean. The console.logs. So yeah, compiling ran one test and it says that we call this particular function and it has been deployed using this private key and this is the owner actually. We deployed this demo data as the arguments in it and it says that okay, this event has been emitted, that election has been created successfully with this demo data and return 0, which is the election ID of it. Okay. And then what we have that okay, get election method we have called with this election ID and it has returned us this data that which is there in that particular election ID. Okay, so yeah, we stopped it and yeah, that's what we get, that we are comparing every, you know, which we did here. We are comparing every name returned and name that we initialized over here and it's getting okay, this is true, 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 everything's true. Our test has been successfully passed. Okay. Now let's try to, you know, on the vote wala test. Test vote successfully. Okay, it says that okay, I have ran this function and it has deployed the contract with this particular uh, private key and this is actually the address of, sorry, this is actually the private key of what am I saying, bro? The user which is trying to vote, okay, which is trying to vote, and this is the owner, as you all know, and he has uh, created an election with this demo data. Okay, and it has emitted that okay, election has been created, and then it says okay, return the election ID which is 0, and then we have called the vote function for this particular election ID 0, and we have to vote for this particular candidate named Alice. Okay, this is okay, your event voted successfully is when successfully emitted for this particular by this particular voter. This is the address of that user who is trying to vote and this is the election ID and this is the candidate name. Okay, so yeah, we'll try to get the candidates for this particular election ID and we'll get exactly what we wanted. We'll try to compare the returned you know candidate name with the ls, and it will pass securely. So that means our test has been passed. Pretty cool, pretty cool, pretty cool. So yeah, that's what we learned today. We learned how to write a Solidity smart contract more efficiently. That's what we are doing every day. We are writing more and more smart contracts so that we can gain hands-on experience on how to make your contract more scalable, more secure, and more ready to deploy. Okay, and also plus one what we learned today is that we can write test files for our smart contract so that we don't have to write all those console commands over and over. So yeah, that's it from my side from today. Tomorrow we'll dive deep into more complex things for sure. Till then, keep tuned.